we're going to look at the revision for paper 1. Paper 1, which is climate and geomorphology. Yes, by the end of this lesson, you will have an overview of paper 1. Dear learners, remember, taking time to prepare for examination requires you to make temporary sacrifices for lifetime investments. You just have to do it. Remember, this is just one examination of many examinations of our lives that you have written and you are still going to write. It is important for you to do well in this examination. However, there is no examination that is more important than your life. Doesn't matter how your results come out, you still have to stay alive. That's the advice that I want to tell you, but that does not mean you have to perform poorly or not prepare adequately. If you have prepared adequately, the results will come automatically. Now, let's go through and see what's in store for us. The date for the paper 1 final examination is going to be on Wednesday, 5 November 2024. You start at 9 o'clock until 12 o'clock. It's 3 hours paper. However, remember, you must be seated by 8 o'clock so that you can gather your mind and you get ready. Don't get to examination very late. Let me give you some examination tips in regard to geography examination. Be seated in the exam room by 8 as per exam rules that are read to you every day. Remember to enter the room with all the necessary Mapwork equipment. Remember, all your papers have got 30 marks Mapwork on them. You must bring a blue pen. An extra pen is very important, even if it's 2 extra pens. You must bring in a sharp pencil, 50 centimeter ruler, preferably a see-through a ruler that you can put on the map and still see underneath so that you are accurate in your measurement. You need a calculator because you might need to calculate in your theory part as much as in your Mapwork part. So you need a calculator because no cell phone is allowed. So the only tool that you can use for calculation will be your calculator. You need your protractor. Make sure that you get a good night rest prior to your examination. Do not go out there and cross night at night before you write the examination. You'll be exhausted the following day. Eat your breakfast so that you can fuel your brain. To answer some of the examination questions, you need to understand the difference between explain how, and explain why questions. These are the questions that we say they need a factor and a qualifier. These are the factors and qualifier questions. You have 2 parts to the question. You need to make sure that you respond to both parts, the explain and how part. Interpret your diagrams and maps. You need to read a synoptic weather map. You are also going to need to interpret and understand case studies or articles that could be given to you in that examination. You need to analyze infographics to be able to answer questions. Remember, your infographics are made of different types of forms. It can be a case study plus a map or a photograph or any other picture but they will be of related content. Now let's look at the structure of our paper 1. It is physical geography out of 150 marks for 3 hours. Question 1 is climate and weather. It's made up of 2 short questions and then 2 long questions, source-based questions. out of 60. And question 2, geomorphology, is the same. 2 short questions of 15 marks, 7 or 8 and 8 and 7 respectively. And lastly, it's a Mapwork question of 30 marks. And the Mapwork question is made of Mapwork skills, application and interpretation. And last marks for 8 marks is GIS. Each question that you're writing will have a paragraph question in question 1 and 2, and all questions in geography are compulsory. Never leave a blank space. Try to answer all the questions. Now, let's start with your examples of your short objective questions. Now, what we have here, we have a synoptic weather map. Let's look at the first question. It says, the synoptic weather map above represents the season. Now you have 2 options, winter and summer. So this requires you to be able to interpret the map or the synoptic weather map. How do you tell that season on the map? How do you identify the season on the map? Now, when you're looking at this map here, dominantly you have L, which indicates low pressure in the interior of the map. So what does that mean? It shows that the season here is summer. Why do you say it is summer? Remember, L is representing pressure. And remember, pressure and temperature are inversely proportional, or they are opposite. When temperature is high, the pressure is low. And when the temperatures are low, the pressure is high. So which means if this was a winter map scale, it will have an H in the interior. But this one is a summer synoptic weather map because you can see it has got an L in the interior. Now, here are the questions. The synoptic map above represent what season? The season that is represented there is summer because of the reasons that I gave, because of the letter L there. And you can also see the mid-latitude cyclone is further south. Remember, the mid-latitude cyclones or cold fronts are always there on the map. They will always be there. The only thing is that they are going to vary in their position. They will move further south. As you can see here, if this mid-latitude cyclone was to move from west to east like this, because it is driven by the westerlies, it will not touch the land because it is during summer. So the land will not have influence. So the question that usually comes in examination, they say, during which season do mid-latitude cyclones affect the weather? Or they ask, during which season do mid-latitude cyclones occur? You must know that the mid-latitude cyclones occur throughout the year. But when do they affect the weather of South Africa? They affect the weather of South Africa during winter because they move northwards during winter. So when they move northwards is when they are closer to the land. And then when they say which season, you don't say because of the presence of the mid-latitude cyclone. You say the mid-latitude cyclone is approaching. The mid-latitude cyclone is approaching. You can see the mid-latitude cyclone here. It is approaching the land, but here it is not approaching because it is summer. It is further. So the mid-latitude cyclone is further south. So during winter, you say the mid-latitude cyclone is approaching. Here it is further south. So it does not affect the weather. Let's go to our next question. It says the weather station model at X. Here is the weather station at X. Then they say it's in the cold sector or warm sector. So when you're looking at the area behind the cold front is called the cold sector. But this one over here is a warm front. So behind this area over here, this whole area behind the warm front is called the warm sector. Is the area behind the warm front. This will be a tip of the warm front. And again, what you should know about the warm front is that the warm front hardly ever, or it never affects the weather of South Africa during summer or during winter. The warm front never affects the weather of South Africa. Why? Because it is always further south. So it is further south during winter. It is even further or furthest during summer. So it never affects. So it's a common examination question. They can ask you between these two fronts, which front never affects the weather of South Africa. You must know the front that never affects the weather of South Africa, it is the warm front. The reason that it is further south every time. Now, our next, the weather station model at X, we said it is in the warm sector. Why warm sector? Because it is found behind the warm front. Then the temperature in Lesotho will be mostly probably be high. Why will the temperature in Lesotho be high? Here is our Lesotho here. Why will the temperatures be high? Because we said temperature and pressure are inversely proportional. And the letters that you see here, the L and H, are representing pressure. So when you see L, it shows low pressure. And low pressure is created because the air is warm and it is rising. So here, the temperatures here will be warm because you see the pressure being low. The area of constant pressure between two highs and two lows at W. So we're looking at this W here. We're looking at this W here. Then we're saying the pressure, the area of constant pressure between two highs and two lows here. This is what we call a saddle. The area between two constant pressure is called a saddle. So which means now you have your high pressure that side, you have your high pressure this side. The area between these two high pressure cells is called a saddle. And the pressure cell found at U is the U. The pressure found at U. So here is the pressure found at U. I believe you studied your high pressure cells. So you have this one over here, you have the other high pressure here. So what will be the pressure cell then? It is the South Atlantic because it is found in the Atlantic Ocean. And then the next question, the pressure reading at the cut-off low in Mozambique is HPA. What HPA? Is it 10, or is it 1008? So what do? You go there, you say this Mozambique, the isobar is not given. So it is given here. But what you should know is that the difference from one isobar, what is an isobar? Is a line that joins places with the same atmospheric pressure. So difference between one isobar to another is 4 millibars. So when you go there, you're going to say 10, 12 minus 4, then this one is going to become 1008. That's how you get to that 1008. And then you could do the same if they ask you what is the air pressure at any. Okay, you can see here this is a low pressure and the pressure here is 1600 millibars. And then because this is a low pressure, it means when you move away, the pressure will increase. But this one is a high pressure, meaning that when you move away from U, the pressure will increase. When you move away from U, you're moving outwards, the pressure will increase because this is a center of higher pressure. So it's 1020, it will be 1024. So it will increase like that when you move away from high pressure. But you must know it will increase by 4 millibars or 4 hectopascals. So what is the correct answer there? Is 1008. The wind direction from U to X will most likely be in which direction? So this is the direction from U to X. From U to X, what is this direction? So it's an easy direction. It's a grade 10 content. It's simple map direction. So the direction there will be to southeasterly direction. The direction is in the southeasterly direction. Okay, now let's go to the next short objective question. This is Eben Heath Island. These are the questions on Eben Heath Island. It says here, evapotranspiration is dash in the rural area because open spaces reflect dash energy out to space. So it means now evapotranspiration in is it low or is it high? Is it solar or is it terrestrial? So you have to mix these ones. Now, what is the correct answer there? The evapotranspiration is higher in rural areas because open spaces reflect solar energy into outer spaces. And now, cities experience less wind circulation because, number one, remember tropical cyclones. Why do tropical cyclones die over the land? Because of high friction. So what do tall buildings do? Tall buildings reduce the wind speed. So the cities experience less wind circulation because of the tall buildings. So there is less wind circulation there. It is not because buildings have more glass. More glass will influence urban heat island. It is not because buildings are of darker materials. Darker material will also favor urban heat island, and therefore, because dark material absorb heat, and then buildings are built of concrete, it will also favor the development of urban heat island. So the only answer here that is going to influence the wind circulation will be tall buildings. All these other factors are factors that influence the development of urban heat island. Let's go to the next question. This is not a reason for the development of the heat island. Number one, we have artificial surface. No, artificial surface does contribute to that. Artificial source of heat does contribute to heat. Density of buildings, yes, it does contribute to urban heat island because it provides larger absorption area. So which one is incorrect is the slope aspect. It doesn't matter where the sun is coming from. It doesn't matter. Remember, slope aspect refers to the direction to which the slope is facing. So this is not a reason for the development of the heat island. It doesn't matter where the slope is facing to. So all these other factors favors. All these other factors favors the development of heat island. There's only one that does not favor the development of urban heat island, which is the slope aspect. And then they say the pressure gradient that exists between the rural area and the city is mainly because. Now, this is an important question because you speak of pressure gradient. So you need to define what is pressure gradient. Then HP minus LP is equals to PG. So what do I mean by that? I say high pressure minus low pressure is equals to pressure gradient. So which means now the pressure gradient that exists. So when speaking of the pressure gradient, we're referring to that there is high pressure somewhere and there is low pressure somewhere, and that results in pressure gradient. So pressure gradient simply means the difference between high pressure and low pressure. So they say the pressure gradient that exists between the rural area and the city is mainly because the first answer is there is high pressure in the city. Now you ask yourself, why will there be high pressure in the city? What is the difference between cities and rural areas? Cities are warmer. So because they are warmer, the air rises. Because the air is rising in the city, so it means there is no high pressure in the city. The pressure is lower. So this one is going to fall out because of low pressure in the rural area. Now you're saying, what creates low pressure? Low pressure is created by high temperatures. Now, are temperatures low in urban areas? No. Remember, we're talking about urban heat island. So when you define urban heat island, you're saying the warmer urban area than its surrounding rural areas. So which means now the rural areas must be cooler. So if the rural areas are cool, it means they cannot have low pressure. Because they are cool, the air is heavy, so the air is sinking. So this one cannot be the correct one. Now the next one says high pressure in the rural area. Now high pressure, what will create high pressure in the rural area is because the air is cooler, so the air is subsiding. So this is the correct one. Now this one says high temperature in rural area. No. Now why are rural areas not cooler? Because in rural areas there's less industrial activities, there's low building density, there is a lot of short buildings, there's natural surfaces, so the rural areas are cooler. So this one says high temperatures in rural areas. So this one is incorrect because rural areas have got lower temperatures because of the natural surfaces, because of open water masses, because of the trees that are absorbing heat. So rural areas are cooler. So because rural areas are cooler, they are going to have high pressure. Then the air will be blowing from rural areas to urban areas. So high pressure in rural areas and low pressure in urban areas. So the correct one here will be number C. Now, let's look at this other one. The dash is or are responsible for the reduced insolation in the city. So what is this statement telling us? That there is less insolation, there is less solar energy that is able to reach the city. So now, when you look up here, you can see a line there. You can see a line there of pollution dome. You can see the line that represents pollution dome. What is pollution dome, by the way? It is the polluted air in or around the city, but it is a concept. It is a concept you can define in any way. You can say a parcel of polluted air in the city. It can be defined in a number of ways. So the area responsible for the reduced insolation in the city, can it be pollution dome? Can it be tall buildings? Will tall buildings reduce insolation? How will they do that? Can the sun reduce insolation? The sun is the source of insolation. Can reflection be the source of reduced insolation? What will be the correct answer? The pollution dome. So this is the pollution dome. So the sun's rays are bouncing off the pollution dome, and therefore they reduce insolation in the city. Then the pollution dome expands during the day mainly. So what does it mean? It means now the shape of the pollution dome. The shape of the pollution dome during the day will be a little bit higher. The shape of pollution dome during the day, it will expand during the day and it will go lower during the night. So the question is, the pollution dome expands during the day mainly because of more human activities, cloud cover, heat islands, or evaporation. So why will temperatures be higher and make this pollution dome to go higher during the night, during the day? It is because of more human activities. The main cause of the dome in the diagram above. So this is the diagram above. What is the main cause of this pollution dome? Now we're looking at reflection, we're looking at air circulation, we're looking at ebb and flow, we're looking at solar radiation, we're looking at reflection, we're looking at infrared, we're looking at dome dust. So the main cause of the dome. So what is causing pollution? So pollution dome, remember we're talking about polluted air in the city. So of all these answers, what is pollution? Which one create pollution here? So the answer becomes dust. That's the main cause of pollution here. The dust is the one that is causing pollution here. Okay, let's move on to the next question. This is another short objective question. The climatic phenomenon represented by AB is the katabatic or moisture front. This is your line AB. What is this line AB? It is a moisture front. So moisture front, you need to define what is a moisture front. Is a line that separates warm, moist air from cold, dry air. So this is your warm, moist air from the Atlantic Ocean, and this is your cold, dry air from the South Atlantic Ocean. So this is your moisture front. The reason or the season represented in the figure is winter or summer. What is a line thunderstorm? What is the moisture front going to do? Is going to give us line thunderstorm. During which season do we receive line thunderstorm? Or during which season do we experience this heavy rainfall? We experience this heavy rainfall during summer. So the correct answer there will be summer. It says line AB indicates a ridge or a trough. Now you need to know the difference between a ridge and a trough. Now, what is this? This is a low pressure, and the low pressure is extended. So an extended low pressure, a trough is an extended low pressure. Low pressure is a trough. Once it is extended like this, it's called a trough. Now, this one over here is a high pressure. So once the high pressure becomes longer like that, or it is extended like that, what do you call it? We call it a ridge. So now you know two concepts here. You know what is a ridge. A ridge is an extended high pressure, and you know what is a trough. A trough is an extended low pressure. So what is the correct one now? The line thunderstorm occur along the trough line. So this line thunderstorm, this moisture front here is a trough line, because the reason why we have clouds is because the air is rising, and the air will only rise when the temperatures are high. And then this is going to result in what you call trough line. This is a trough line, and it occurs during summer. And then the air mass at D is influenced by here is your D, is influenced by the warm Mozambique or cold Benguela current. It is influenced, okay, I think I skipped 1.1.4, I'm sorry. At C, there is cold and dry, warm air, cold and dry, or warm and moist. At C. Here is your C. So this is Atlantic Ocean influenced by the cold Benguela current. So the air here is cold and dry. The air mass at D is influenced by the warm Mozambique current or cold Benguela current. This is grade 10 syllabus. So you know the ocean current on the east will be the warm Mozambique current. Air mass C. Air mass C. Here is the air mass at C. Undercuts or overrides. So undercuts meaning that it goes underneath, or override meaning that it goes on top. Air mass D along the AB, which is the moisture front. This line over here is called the moisture front. This trough line is called a moisture front. This trough line over here is your moisture front. So the question is, the air mass at C is going to undercut. Now you need to know the characteristics of this air mass. This air mass is cold and dry. So it's cold and dry, therefore it's denser. So what will be the answer there? The answer for this question will be, it is going to undercut. It's going to go beneath. It is going to go beneath because it is heavier. This one over here on the east is warmer, so it will override. It is the one that's going to go above. Now, the air at D originates from the South Atlantic or Indian Ocean. At D, is it South Atlantic or Indian Ocean? It comes from the Indian Ocean. And lastly, the common type of precipitation east of line AB will be advection or a thunderstorm. So on the east of moisture front, this is where you're going to get this line thunderstorm. This way you're going to get the line thunderstorm on the east of the moisture front. So the common type of precipitation east of the line AB will be line thunderstorm. And why? Why are we getting line thunderstorm on the east? Because on the east, the air is warmer. Because the air is warmer, it rises, and it rises rapidly. And because the air rises rapidly, it condenses. On the east, the air rises, it rises rapidly, and it rises higher, resulting in the development of cumulonimbus cloud, the CB clouds. And then what is the weather associated with cumulonimbus clouds? It is heavy rainfall and thunderstorm. Weather associated with cumulonimbus cloud is heavy rainfall and thunderstorm. So because the air on the east is going to rise rapidly, and after rising rapidly is going to rise even higher, is going to result in the clouds that have vertical extension. The clouds that have got vertical extension and that are heavily laden with moisture. They've got a lot of moisture, and then therefore is going to result in the development of thunderstorms and heavy rainfall on the east of the moisture front. Now, let's look at the long questions here. The first long question that I want us to quickly look at is the tropical cyclone here. State one condition that are required for the development of tropical cyclone. Give two pieces of evidence from the sketch to indicate that the tropical cyclone is in the mature stage. Now, let's look at the first question. State one condition required for the development of tropical cyclone. So, what is it that tropical cyclones need? Tropical cyclones need the temperatures of 27 degrees and above, plus 27 degrees temperatures above, but it must not just be temperatures of 27 degrees and above. It must be ocean temperatures, because it doesn't matter what temperatures are, so long as they are not on the ocean or in the ocean, that will not favor the development of tropical cyclone. It must be surface water temperatures or ocean temperatures of 27 degrees and above, not just temperatures of 27 degrees and above. And number one. Number two, what do tropical cyclones need to develop before 27 degrees temperatures and above? They also need Coriolis force. They need Coriolis force because Coriolis force is the one that results in the rotation of the winds. They need Coriolis force. And then they also need high level of evaporation. What is the importance of high level of evaporation? Is to create low pressure or create intensive low pressure, because the air is rising. Now the pressure is getting lower and lower. And then where will this tropical cyclone get their energy from? They will get their energy from latent heat. So those are the conditions that are necessary or that are required for the development of tropical cyclone. You said 27 degrees Celsius and above, but ocean temperatures of 27 degrees and above, they also require what? Tropical cyclones also require Coriolis force. Coriolis force. What is the importance of Coriolis force? Is for the air to be able to rotate or to spin. And then also it requires high level of evaporation. What is the importance of evaporation? Evaporation, remember, is going to result in low pressure or intense low pressure created on the surface. And again, this is the low pressure, that is the evaporation that will further result in the release of latent heat to the tropical cyclone as the energy source for the tropical cyclone. Because the tropical cyclone needs energy. And where does tropical cyclone get their energy from? From the latent heat. Give two pieces of evidence from the sketch to indicate that the tropical cyclone is in a mature stage. How do you tell that this tropical cyclone is in a mature stage? Number one, you can see it has got an eye. It is well developed here. You can see from the cross section. You can also see from the sketch here that it has got an eye. That's number one. Give pieces of evidence from the sketch to indicate that the tropical cyclone is in the mature stage. So you can see there is an eye there to indicate that it's in a mature stage. It's clearly visible there. It is clearly visible also in the cross section. What else can you see there? What else can you see there? You can see the pressure, which is below 1000. The pressure is below 1000. So the pressure in the center here is 970. Is 970. So the isobaric interval in this case, it is 2 millibars. In this case, the isobaric interval here is 2 millibars. So the pressure in the center there will be 970 millibars or hectopascal. So it's indicating that the tropical cyclone is in a mature stage. What is the evidence? This is the evidence. And then again, it is important that sometimes the examiner can ask you to draw a symbol to represent the eye of the tropical cyclone. You see, that is the eye of the tropical cyclone. That is the eye of the tropical cyclone. This is the symbol for the eye of the tropical cyclone. It must be represented like that. Give a reason. Okay, what influence will subsiding air at A have on the cloud cover in the eye? So if the air is subsiding here in the eye, what influence will the subsiding air at the eye have on the cloud cover in the eye. So what are the conditions in the eye of a tropical cyclone? Number one, the conditions is that there is clear skies. It's clear skies. Why do we have clear skies in the eye of a tropical cyclone? Because of the subsiding air. So subsiding air will not condense because subsiding air is heated adiabatically. So the adiabatic heating that we experience when we're talking about air, it will occur when we're talking about, number one, the berg winds. The berg winds, why are berg winds hot and dry? Berg winds are hot and dry because they are heated adiabatically, meaning that as the air descends, it is heated. So during the occurrence of berg winds, do we have clouds? We don't have clouds. So it's the same condition. That is the same condition with the eye of the tropical cyclone. In the eye of the tropical cyclone, the air is subsiding. So a subsiding air is heated, and because the air is heated, there is no condensation. So I'm bringing these two concepts together because now we are doing revision. We have already done berg winds. We know they are hot and dry winds. Why are they hot and dry? Because the air is subsiding. Now, what's happening with the subsiding air? The subsiding air is heated. So those conditions are the same in the eye of a tropical cyclone and also with the berg winds. The air is subsiding, and what is the behavior of subsiding air? It is heated. And now when the air is heated, there is no cloud formation because the air is not going to condense. The air will only condense when it rises. And rising air is going to cool. And then the cooling is the one that is going to result in condensation. But the subsiding results in heating. Rising results in cooling. So I hope you understand why we are going to have I hope you understand what will be the influence of subsiding air in the eye of the tropical cyclone. It's going to result in clear skies, and then other conditions that we are going to get in the tropical cyclone's eye is that there is no precipitation. You cannot expect precipitation without clouds. And then another condition that you'll get in the eye of a tropical cyclone is that it's going to be calm condition. The conditions will be calm in the eye because this is what we call the eye wall. These cumulonimbus clouds here, they form what we call the eye wall. Because of the eye wall, the strong winds cannot go through the eye. The strong winds cannot go through the eye. That is why one of the conditions is that it is calm or wind still. It is calm or wind still in the eye of the tropical cyclone. Is because of the strong cumulonimbus clouds or thick cumulonimbus clouds that stops the wind from blowing into the eye. So you know the conditions in the eye. You know it's clear skies. Why clear skies? Because the air is subsiding. Subsiding air will not condense. That is okay. I've already given the reason why we are going to have clear skies. We're going to have clear skies because the air is subsiding, and because the air is subsiding, the air is going to be heated, and when the air is heated, that air is not going to condense. That is why we don't have clouds in the eye of the tropical cyclone. Now, indicate the relationship between the wind speed and air pressure as indicated by the graph above. This is our graph above, and then this point over here will be at the eye of a tropical cyclone. Now, what are we looking at here? We're looking ahead of the eye, before this eye comes. So, ahead of the eye will be at this point. Ahead of the eye will be at this point. So, ahead of the eye, wind speed will be high and the air pressure will be low because you can see the air is rising there. You can see the air is rising there. It shows that there is it shows that the pressure is low here because the air is rising. So ahead of the eye, we are going to have high wind speed and we are going to have low pressure. And then with thin an eye, what's going to happen with thin an eye? Because the air is subsiding, it creates high pressure, and within the eye, because of these cumulonimbus clouds that stop the air from blowing in, we are going to have a very low wind speed. There is calm condition in the eye of the tropical cyclone. Now, the next question, last question of the tropical cyclone says here, how does the leading or left quadrant dangerous semicircle develop in the tropical cyclone? The tropical cyclone is moving from east to west. Why does it move from east to west? It is driven by the tropical easterlies. Tropical cyclones are not driven by the easterlies. They are driven by the tropical easterlies. You cannot give an answer that says easterlies because, number one, we have two sets of easterlies in our circulation. We have polar easterlies and tropical easterlies. So the answer has to be specific. It must be tropical easterlies. Now, this is the general direction of the storm from east to west because they are driven by tropical easterlies. And now when you're looking at the circulation of air here, it is also from east to west. The air circulation, remember this is a clockwise circulation. The air is circulating in a clockwise direction. So because of this clockwise circulation, at this point, the circulation is to the east. At this point, the circulation is to the east and the general direction is to the east. So that is how the dangerous semicircle develops. How does the leading or left quadrant dangerous semicircle develop? It develops when the general direction and the circulation direction are the same. The general direction from east to west and the circulation direction are also from east to west are the same. General direction are the same as circulation, east to west. So that is when the tropical cyclone is going to have that dangerous semicircle. So these are the answers that we spoke. Now we're looking at other source-based question. This is representation of the summer condition. Now, what is the question? The first question says, identify one factor in sketch A that influences the weather of South Africa. So this is sketch A. So what is influencing the weather of South Africa here? It is South Atlantic, it is Kalahari high pressure, it is South Indian, it is cold Benguela current, it is Mozambique. That's not even a question. This was just a teaser. It's so easy. You just look at any of the factors here and you get a free mark here. And now next question, how would the position of the South Atlantic high pressure influence the moisture content of the air reaching the east coast of South Africa in summer? How would the position of the South Indian high pressure influence the moisture content of the air reaching the east? Now, the South, now what has happened now with the high pressure? The high pressures, remember we said they are following this high pressure cells, they are following the migration of the ITCZ. So when it is summer, they move further south, and then when it is winter, they move further north. They move in this direction. They move further south and north according to different seasons. And then Kalahari high pressure does not move south and north, it moves up and down. So it is higher during summer and it is lower during winter. This Kalahari high pressure. It moves up and down. This one moves north and south. So the question is, how would the position of the South Indian high pressure influence the moisture content of the air reaching the east coast of South Africa in summer? So what does it mean now? It means during summer, the South Atlantic high pressure is further south and therefore is going to allow warm moist air to enter the interior. And this warm moist air in the interior will now condense because it's going to rise and cool. After condensing, it's going to result in the cloud and the clouds will result in precipitation. So how would the position of the South Indian high pressure influence the moisture content of the air reaching the east coast of South Africa? What do you say in summer? saying that because the South Indian high pressure is further south, it allows the warm moist air to go into the interior, and therefore it allows warm moist air to come into the interior. Why is the Kalahari high pressure weakly developed over the land in summer? This is your Kalahari high pressure. Now you can see the inversion layer is above the escarpment here. Why is this the case? It's because the Kalahari high pressure is higher in the atmosphere. And then why is Kalahari high pressure higher in the atmosphere? Because there is strong convection. There is strong convection. So there is a lot of rising warm air, convection or vertical movement of air. So the question says, why is the Kalahari high pressure weakly developed over the land in summer? It is because, number one, we have strong convection. There is more rising air. And now the question can be opposite. It can say, why is the Kalahari high pressure weaker or stronger during winter? Why is it stronger during winter? It is stronger during winter. So you can just change this and say, okay, here this one is saying weaker. You can change the question and say, put the opposite of that question, say, why is it stronger during winter? Then change summer to winter. Then it is stronger during winter because there is strong subsidence. There is strong subsidence. Remember now we're saying there is strong convection during summer, and during winter there will be strong subsidence. And then this during winter will mean now, because of strong subsidence, the inversion layer, this inversion layer will move below the escarpment, and trap warm moist air. So this one indicates a weaker Kalahari high pressure. This one will indicate a stronger Kalahari high pressure. So this is what will happen for different seasons. And this layer, remember, we call it the inversion layer. This layer is called inversion layer. It's called inversion layer because it is at the plateau. If it was in the valley, we will call it thermal belt, but it indicates temperature inversion, which the increase of temperature with height. The increase of temperature with height. So many times learners confuse the concept inversion layer and thermal belt. You only get the thermal belt. You only get the thermal belt in the valley. You get the thermal belt in the valley, but at the plateau, here you get inversion layer. Though they are same, they cannot be called with the same name. They cannot be called with the same name because they, even though they are both indicating the increase of temperature with height, which is temperature inversion. Temperature inversion is the increase of temperature with height. You will see here temperature inversion in the plateau here because of the weak and strong Kalahari high pressure. You'll also get that in the valley, but you cannot use the two concepts interchangeably. Inversion layer remains at the plateau and the thermal belt remains in the valley. That's how you should know them. Now, how does the weakly developed Kalahari high pressure cell influence the presence of the inversion layer in sketch B? How does the weakly developed Kalahari high pressure cell influence the presence of the inversion layer in sketch B? This is our sketch B. How does the weak inversion influence the presence? Weak Kalahari high pressure. Now, how does it influence it? The inversion layer is above the escarpment. So you can ask that question in opposite direction and say, how does the strong Kalahari high pressure influence the position of the inversion layer? You can say it goes below the escarpment. But for this question here, it says, how does the weakly developed Kalahari high pressure cell influence the presence of the inversion layer? Now you say the inversion layer is above the escarpment. So if you ask this question in opposite and you say, how does the strong You see, how does the strong developed Kalahari high pressure cell influence the presence of inversion layer in sketch, whatever sketch, or in winter, you say it goes below the escarpment. Okay, I am not going to just go through the questions that are asked here. I'm going to go through possible ways in which these questions can be asked so that you are better prepared for your paper. Now, the next question says, in a paragraph of approximately 8 lines, explain how the position of the inversion layer will bring overcast and unstable weather conditions over the interior of the country in summer. In a paragraph of approximately 8 lines, now you are stated how long must the paragraph be. But we said the length is not so key to the to this question. What is more key to the question is that you must look at the allocation of marks. The question wants you to give 4 answers. So it says, explain how the position of the inversion layer will bring overcast and unstable weather conditions over the interior of the country in summer. So there is a weak subsidence of air over the plateau. There's going to be weak subsidence over the plateau, number 1, and the land is going to heat up excessively over the central interior. The warm moist air from the warm Mozambique current will reach from the South Indian up the escarpment, and the warm moist air will reach the interior of the country because the inversion layer is above the plateau. There is lots of cloud formation. There's going to be widespread of rainfall during summer. So in a paragraph of approximately 8 lines, how the position of the inversion layer. Okay, now it's very important that you are able to respond. It's very important that you are able to respond to this question for both summer and winter. What will happen during summer? The inversion layer is above the escarpment. Warm moist air goes into the interior. Warm moist air condenses cloud formation. Cloud formation is going to result in precipitation during summer. But during winter, the inversion layer is below the escarpment. And when the inversion layer is below the escarpment, warm moist air cannot go into the interior. If the warm moist air cannot go into the interior, there's no condensation. It's going to result in the stable conditions. But here we're talking about the unstable condition, indicating that the air is rising. But for winter, we're going to have stable conditions, meaning that the air is denser and it's sitting on the ground. It's not going anywhere. Now, let's quickly run to geomorphology. Let's quickly run to geomorphology questions and see what questions we have here. Okay. In introduction to geomorphology here, we simply have what we call water cycle. You can see precipitation is there, and you must know how to define precipitation. And then vegetation, you have transpiration, you have surface runoff, you have infiltration. So infiltration is simply referring to the absorption of water by the surface. And that's your percolation of water there. And through flow is the flow of water beneath the surface. That's what you get there. And groundwater is the water found beneath the earth's surface. River discharge refers to the volume of water as it passes a specific point at a specific time. So this is just an icebreaker to our geomorphology here, this water cycle. Let's look at the questions here. High-lying area that separates 2 drainage basins is known as the watershed. Point where 2 or more streams meet is known as the confluence. So easily, if you're looking at 2 streams, your confluence will be this point here, where this point over here will be your confluence, because you have this stream that is flowing into this stream. So this point over here will be your confluence, because that's where 2 streams meet. So any point where 2 streams are meeting, that point is called a confluence. Okay. And then a watershed is high-lying area that separates two drainage basins. Here we have an interfluve. So what does an interfluve do? If you have a drainage basin like this, and a drainage basin with the streams, this is one drainage basin with streams. So between the streams within one drainage basin, this is what you're going to get, an interfluve. But if you have one drainage basin here and another drainage basin next to it there, so the two drainage basins are separated by the watershed. Point when two or streams meet, we already said that it is confluence. Point where the river enters the sea is known as the mouth. But you should not say mouth, just like you could not say elbow when you're talking about river capture. It is not elbow, but it is elbow of capture. And also here you must be very aware, it must be river mouth, because it's not just any mouth, it's a river mouth. And then the elbow of capture, the point where river join or river diverts headwaters of another river, or a stronger, more energetic river diverts headwaters of another less energetic river. That point is not called an elbow. It's called an elbow of capture. Just like here, this is not necessarily a simple mouth, it's a river mouth. The upper limit of groundwater now, where do we go here? We go to the upper limit of groundwater. So if you have water, groundwater here, so this part of groundwater here, this part of groundwater will be the part that is on top here, the top part of groundwater. This is what we now call water table, this top part of the saturated. So this top part over here, this is what you call water table. The top surface of groundwater is called water table. And now the process, okay, base flow. Let me quickly go to base flow. I didn't look at base flow here. So this is what we call base flow, when water is flowing beneath the earth surface. When the water is flowing beneath the earth surface, we call that base flow. And then runoff is when the water is flowing on the surface. Infiltration, the process whereby water seeps under the ground, or the process where water is absorbed by the surface, we call that infiltration. The area drained by a river and its tributary is called the drainage basin. And then what we call the river and its tributary, we call it the area drained by the river system. So you can say it a river and its tributary, or you can say river system. The area that's drained by the river system is called drainage basin. So the river and its tributaries, they are together called a river system. A river that originates in areas of high rainfall but flows through dry area is known as the exotic river. So what is an exotic river? Is a river that has got the source in the highest, in the upper course of that particular river. There's high rainfall. But as that river flows lower, it flows past a dry area or a semi-arid area. So when that river passes through that point, it is known as exotic river. Now let's quickly go through these short questions on drainage patterns. Tributaries join the main river at right angle. Which one has a main river joining at right angle? So both of this A and B. So that question will be for both. So this, when you're naming this will be a trellis pattern, and this one will be rectangular pattern. So the rectangular pattern, tributaries join the main river at right angle. So it's got characteristics of both. So trellis pattern, the tributary join at right angle, and also with the rectangular pattern, the tributaries join at right angle. So both A and B will be correct here. There are right angle bends along the course of the main river. So this will refer to B. The pattern occurs in folded mountains. So this one will be A, which is trellis pattern, and then develop in areas where faults occur parallel to each other. So it will refer to the rectangular pattern. So when you're looking at the underlying rock for a rectangular pattern, you say it is found in the rocks that have got faults or jointed igneous rocks. This is your this one will be your B, where there are faults or there are joints. Develop in areas where the faults occur parallel to each other. So this one over here, so there's a fault parallel to each other here. This one over here will be your fault. So long as you see the word faults there, the faults are parallel to each other, that one will be B. Tributaries are short, so your tributaries here are your short tributaries here. So this will be your A, your trellis pattern. Tributaries often flow from gaps or pores. So if the tributaries are joining from gaps or pores, so it will form on this trellis pattern. Now let's go to the next question. Short objective questions. Short objective questions. Now let's look at this river profile. The longitudinal profile in a diagram represents, so this is telling you that this is a longitudinal profile. So now what is a longitudinal profile? It is a view of the river from this point that we call the source of the river, where the river originates, and the point where the river enters the sea, which is called the river mouth. So because you are looking at the river from that point to that point, we call it what? A longitudinal profile. Is the review of the river from the source to the mouth. We call it a longitudinal profile. So they're saying this longitudinal profile of the river represented here is graded or ungraded. Now you're looking at the characteristics of the river here. What is the correct answer there? It is ungraded. So why do we say this river is ungraded? Because it has got nick points. Because there's a nick point which is a waterfall there, and it is uneven. The river profile there is uneven, so it is ungraded. The river course indicated by X on the longitudinal profile is there. At X, this point X here, what is it called? Is it upper or middle? So it is still upper course there. This will be the upper course of the river. Erosion is dominant erosion at X. So where is our X? This is our X. Because it is in the upper course, what type of erosion is dominant there? It is vertical erosion that is dominant in the upper course. And then why do we have dominant vertical erosion in the upper course? Because in the upper course, the gradient is steep, and therefore there's going to be vertical erosion. And then the sharp drop in gradient indicated at B on the diagram is known as A. So here there's a sharp change here in the gradient. It's called a what? A waterfall. So this is a definition of what we call a nick point. This is a definition of what we call a nick point. What is a nick point? Is when there is a sudden change in the gradient of the river. Where there is a sudden change in the gradient of the river. Now, 2.1.5, headward or vertical erosion may result in the removal of the temporary base level of erosion. Which one is that? Is headward erosion. After the removal of the temporary base level at B, the river profile will have what shape? After this temporary is being removed, now the river is going to be flowing here. What will be the shape? What will be the shape here? The shape there will be a convex. Not convex, I'm sorry. Convex will be bending outwards. So this one will be a concave. After the removal of the temporary base level. So after all this are removed, now the river will have a concave profile, and now it will change from being ungraded to being graded. It will change from being ungraded because it's going to have a concave profile, and once it is now concave, smooth concave profile, it is now going to change from being ungraded to be graded. So what do we mean when we say it is graded? It will be in a state of equilibrium. There's going to be equilibrium. Let me write it here. Equilibrium. What do you mean when you say it's going to be in a state of equilibrium? It means there's going to be a balance between erosion and deposition. Right now, in this stage, the question said the dominant erosion. So it means there is a dominant erosion in this. So the dominant process in this river is erosion. The dominant process in this river is erosion, especially in this part, because there are still obstacles, there are still weak points there. So the river is trying to remove them. But once this is removed, there is not going to be any dominant process. The river will be in a state of balance between erosion and deposition. And we say that the river is in equilibrium. And now, because it's in equilibrium, it's going to take a concave shape because the river will have been graded. Now, the flow is predominant on the slope of the river profile indicated as S. Now, what is the stage here at S? The stage at S here is called lower course. It's at the lower course because you can see this is where the river is joining the sea, and then you can see already here the river is already winding, and as the river winds, that process is called meandering. The river is meandering there, and then it indicates that there's a lower course. And then what will be the dominant flow is predominant here. So this is what we call a laminar flow. This is what we call a laminar flow. And then that is when a river is flowing in sheets that are separate from each other. There's no mixing of water at this stage. The river is flowing on separate sheets. That's when we call that process a laminar flow. Why is the river flowing in that kind of form? Why do we have laminar flow? Because the gradient is, the riverbed is smooth. So because of the smooth riverbed, there are no turbulences. So the river is flowing very smooth here. But when you look at here, at Z here, this will be the type of flow that is called turbulent flow. And this kind of river flow will take place in the upper course where there are weak points and there are waterfalls, there are rapids. So at this stage, the river will flow in a turbulent flow. But at this stage where it is smooth, it's going to have a laminar flow. And how do you define that laminar flow? Is when the river is flowing in separate sheets. It flows in separate sheets that are not touching each other. So you can see there, you have the flow there, you have the flow. So it goes like that. So it's indicating that there is no disturbances to water. But at this stage, at Z, you can see the water is bouncing up and down. So there's high chances of this water layers mixing with each other because of the uneven gradient. And then it will happen in the upper course, but the laminar flow, you will get it in the lower course. Now, what we have here, we have drainage basins that have got different densities. The first question is explain the concept drainage density. So when talking of density, we're simply referring total length of streams divided by total length of streams divided by the area drained by those streams. So what evidence indicate that sketch A has higher drainage density? Why do we say A has higher density? There are many tributaries. There are many tributaries here. And then determine the stream order at X in the sketch A. So how do you determine that? You say this is 1 and 1. 1 and 1, they're going to make 2. This is 1. and 2, they're going to remain at 2. This is 1 and 1, they're going to make 2. So you have 1 and 2, it remains at 2. Then you have 2 and 2 is going to result in 3. So determining the stream order at X will be stream order number 3. Stream order number 3. So as we speak of this order, okay, we'll talk about that. Let's finish these questions. Explain the influence of gradient or slope on drainage density. How does the gradient influence density? Now, the gradient and density, they are, if the gradient is steep, there's going to be a high surface runoff, and because of high surface runoff, the density is going to be high. But if the gradient is gentle, there's going to be more infiltration and less runoff, and therefore it's going to be low density. Now, if we're looking at sketch A and sketch B, where do we have a steeper gradient? We have steeper gradient at B. Why do we say steeper gradient at B? Because there are more tributaries, which means there is more water flowing than at A. At A, there is more water infiltrating. That is why we have lower drainage density at A, because of the gentle gradient. Remember, now we're looking at the factors that influence drainage density. Factors that influence drainage density. Here we are given one, which is gradient. We also have vegetation. So now, if we're looking at this, looking at vegetation, which area will have more vegetation? A will have more vegetation, because vegetation is going to result in more infiltration. More infiltration is going to result in low drainage density. Then at B, it means now, we have low vegetation. At B, we have low vegetation. That is why there is more surface runoff. And another factor that will influence drainage density will be also type of precipitation. So what do we mean here? It means that at X, or here at A, the type of precipitation here is soft rain. So soft rain results in more infiltration and less runoff. But here at B, it is heavy rainfall. Therefore, it's going to result in more runoff, which results in higher density. Then you can also look at another factor. It will be soil moisture. Which of the two soils here, soil moisture, which of the two, at A or B, where do we have more soil moisture? At A, there is less soil moisture, which means the surface at A is dry. Because it is dry, more water infiltrates. But at B, it is saturated. Because it is saturated, it allows less water to infiltrate. So most of the water is going to flow on the surface. And another factor that we can look at that will change this density will be, another factor will be porosity and permeability. It will be porosity and permeability. So what's happening here? Porosity. What is porosity? It's pore spaces per unit area. So it means at A, there are more pore spaces. And if you can look at the type of surface, at A, you can say at A, we have sand. And now because of sand, there is more infiltration and less runoff. And therefore, it resulted in A having a low drainage density. And at B, you can say we have clay soil here. You can say we have clay soil here. And here we have sand soil or sandy soil. So here we have clay soil. Because of clay soil, there's going to be low porosity. Because of low porosity, there's going to be low permeability. So porosity influences permeability. So clay soil is less porous and it is also less permeable. Because it is less permeable, then it's going to result in high infiltrate. It's going to result in high runoff and less infiltration, and therefore is going to have higher drainage density. So those are some of the factors that are going to influence. So now, porosity and permeability will also influence drainage density. So at A, the surface is highly porous and highly permeable, resulting in more infiltration and less runoff. But at B, the clay soil is less porous, or it has got less porosity, and therefore it is less permeable. That is why we have what? More runoff. How do you tell there's more runoff? Because the density is high. How do you tell that there's low density? How do you tell this area is high permeable? It's highly permeable because there is more water infiltrating and there's less water flowing. Okay, now let's move. We have looked at the factors that influence the drainage density. Now let's go into drainage pattern in sketch B. Drainage pattern in sketch B and sketch A are the same. The drainage pattern here is the same. It's different in terms of density. So the drainage pattern for A and B will be dendritic. How do you tell it is dendritic? Because it looks like the branches of a tree. It does not look like a tree. It looks like the branches of a tree. And then the tributaries join the mainstream at acute angle. Those are the characteristics of the dendritic pattern. And then those are the reasons. Identify the drainage pattern. We said, what is the pattern? Dendritic for both A and B. For both A and B. Because the difference between A and B is just density. But the shape is the same. It's dendritic pattern. So why do we say? Give a reason. Why do you say it's dendritic? Because it looks like the branches of the tree. And because, again, the tributaries join the mainstream at the acute angle. And then another reason that they can ask you, another question that they can ask you is to describe the underlying rock. Then you say the underlying rock here is the rock with similar resistance. The rock with similar resistance to erosion, or the rock with same resistance. But when you quickly go back to this one, you can say this one, the underlying rock is soft and hard rock following each other. Here we said, here what we have for this pattern, we have jointed igneous rock. We have jointed igneous rock or igneous rock with faults or cracks. Here is folded mountains, but here with this one, here this one we say is a surface with a uniform resistance to erosion. Okay, let's move on to the next one. One of the most common examination questions will be river capture or stream piracy together with river rejuvenation. Now let's quickly look at this river capture questions. What evidence in sketch X indicates that river capture is likely to take place? So what do you do here? You look at sketch X. So you see here is headward erosion. So what is headward erosion? Headward erosion. Remember, this water is flowing and going in this direction. So as this water is going in this direction, now the water erosion is taking place in this direction. Backwards. So what is headward erosion? When the river erodes backwards, or when the river erodes towards the source. So it's eroding backwards. So what evidence in sketch X indicates that river capture is likely to take place? So what do? You look at here, you're saying headward erosion is taking place. Tributary of river A is cutting through the watershed. So this place over here is the watershed. So what is happening here? This tributary is cutting through the watershed. It is also important for you to know what do we call the process where the river is cutting through the watershed? That is called what we call abstraction. That process is called abstraction. So we have two processes here. We have one, headward erosion, where the river is eroding towards the source or backward, and abstraction is the lowering and the removal of the watershed, or is the retreat of the watershed. The lowering and the removal of the watershed is called abstraction. What could have caused the Captor stream to erode through the watershed? Why was this river able to cut through the watershed? Now, you need to know what are the factors that contribute to river rejuvenation. It's because what? It was flowing on a steeper gradient. It was flowing on a softer rock. Because of softer rock, it's going to be easily eroded. It is because of increased volume of water, because of increased rainfall. So this could be asked in a simple way, what are the causes of river capture? So one river must be flowing on a steeper gradient. It must also be flowing on a lower gradient. You can also add here, it is flowing on a lower gradient. It's on a lower lying area. It's also flowing on a lower lying area. Now, what's the next question? Identify features C and B of river capture in stage 1. So where is river C? This is the point here, river C, and this is this point here. This is river D. So identify feature C. So C is the elbow of capture. This is not an elbow, it's an elbow of capture. And it's D is a misfit stream. It's a misfit stream. And now the question can ask you a question, what will happen to, or we can give characteristics of river D after river capture, or we can give the impacts of river capture on river D. So what will happen at D? River D will have less water. Because it has less water, there's going to be more deposition and less erosion. And then it can also be asked a question to give the impacts or the implication it will have. And also when you're looking at river E, look at river E. What has happened to river E? River E has got increased in what you can see that it is thicker in color now compared to this one. So it means it has gained more water. Explain the process that resulted in the formation of feature D. Explain the process that resulted in the formation of feature D. What is feature D? The misfit stream. How did the misfit stream form? How did the misfit stream form? Number one, headwaters of the misfit stream was cut off by the captor stream. So its headwater has been cut off. It continued to flow after the wind gap with reduced supply of water. So what has happened here is that this is the headwaters. Headwaters is the water that is flowing from the source. Now it has been diverted. It has taken another direction. So now this river has a shortage of water. Now, you can also give what will happen to the people that are living around here in terms of their activities. They're going to have less water for farming, less water for irrigation, for household. So those are type of questions that can be asked. It can be asked to give the impacts of this, the impacts to the people or the impacts on the river themselves. So when they say what are the impacts, the physical impact on the rivers themselves, this river is going to have shortage of water, but this river is going to have high volume of water. Now let's look at the final question here. It says, in a paragraph of approximately 8 lines, describe how the increased volume of water will positively impact on the farming community at E. So how will the farming community be impacted here? Now there's going to be more water for irrigation, which means now at D there's less water for irrigation. There's going to be more water for livestock, increased yields due to the abundance of water, decrease in cost to obtain sufficient water for irrigation, so they don't have to spend more money because water is readily available. Increased flooding increases natural fertilization of soil. Input cost to farm decreases, so there's going to be less money spent. Farming now is economically viable. More jobs are created as more areas are put under cultivation. Increase in income as farming yields increases. Increase in domestic water. Increase in nutritional activities. Food security is secure since there is more access to food, more water for aquaculture. So this is the impacts to people. The question can also be, what is the physical impact, or what is the impact on the river? So now what's going to happen to the river? The river is going to have increased volume of water. The river is going to flow faster, increased velocity. The river is going to increase its vertical erosion. Then there's going to be less deposition because river has got more energy, and its carrying capacity will also increase. So here this question was looking for the impact to the people around, or the impact to the people living closer to the river. So this impact can also be on the rivers themselves. So you must be careful. That question can be asked in a number of ways. And again, you should be able, so many times you make a mistake because you give the characteristics of river E at river D. You must know which one has gained water and which one has lost water. So it's very important that you are able to look at those. What you have there, you have fluvial landforms. Identify the fluvial landform at A and B respectively. So when you're looking at this one fluvial landform here, this is your braided stream, and when you're looking at this one here, because you can see there's an ocean here, so B will become a delta. Where in the river will one find the fluvial landform at B? This fluvial landform, which is the delta. Where do you find the delta? At the mouth of the river. Where in the river will you find this? You find it at the mouth of the river or in the lower course of the river. Explain how the fluvial landform A is formed. How is landform A formed? How is stream is formed in the lower course of the river? So what is happening there? As the river is flowing, it deposits the material on its own course. It's happened that there is deposition of sediments in the course of the river. Because it is in the lower course, the river is unable to cut through the deposit. So what does the river do? The river starts to wind around. The river starts to wind around the deposits. So when the river starts to flow or wind around the deposit, it's going to result in different channels, or in number of channels, or the river is going to split in many channels. And as the river splits in many channels, this is going to result in the development of what we call braided streams. And then write a paragraph of not more than 8 lines and discuss the significance or the importance of fluvial landform at B. What is the fluvial landform at B? There's a number of importance of this, and now some of the factors, we can look at them as economic importance, you can look at them as social importance, and can also look at them as environmental importance. Let's look at the importance now of the deltas. They support biodiversity. It means now there's plants and animals that can be found there. It's a habitat for migratory birds that can be migrating from one place to another. They can live in the deltas. They are nursery grounds for marine life. They are natural barriers against storms and erosion. So because there's vegetation around the deltas, this vegetation will also reduce the wind speed. So it stops erosion and reduce the storm. So that's one of the reasons why the tropical cyclones will reduce their speed when they come through the land or over the land, because number one, they start with the friction from the deltas. And now, what will be the economic importance of deltas? Because of the fertile soil, It's good for agriculture. They also support fishing. They are also tourist attraction. The deltas can also be used for human settlements. They can also be used as historical and spiritual sites. People can go there to go and worship and do whatever their interest. And again, deltas are important for education and research. And you can see there, we are also talking about delta in our education system. So it means now it is also important for education and research. Now, let's quickly go through Mapwork activities. What are we going to look at here? So, we're going to look at gradient. So, before you can know how to calculate gradient, you must know how height is represented on the map. Number one, height is represented through using of the contour lines. This the contour lines there on the map. Number two, height is shown on the map through use of the trig station. What is important is the trig station. You must know trig station has got two numbers to it. It's got this full number or whole number 72. It represents that is trig station number 72. And also at the bottom, it's got a number that has got a decimal comma. It shows the height of that particular trig station. Height on the map can also be represented using spot heights. So this is your spot height. It's a spot plus a number. It's a dot and a number. So we call that a spot height. And then also we can use benchmark to represent height on the map. So this is a benchmark. You will usually find the benchmarks on the sides of the roads. Okay, now let's calculate vertical exaggeration first. The formula for vertical exaggeration is equals to vertical scale over horizontal scale. Vertical scale over horizontal scale. Now, your horizontal scale is always given. Your horizontal scale is always given. So when you calculate vertical exaggeration, you do vertical scale over horizontal scale, and you know your horizontal scale is always given on the map. But your vertical scale, what is your vertical scale? Your vertical scale is not given. You work out your vertical scale. How do you work your vertical scale? You look at your contour interval. And you must remember, your contour interval is always in meters. Your contour interval, height on the map is shown in meters. So your contour interval will also be in meters. Now, let's try to calculate, try to do a general calculation of vertical exaggeration. Now, if you calculate vertical exaggeration, now you have to know now your contour interval. You say now, how it is 20 meters. Your vertical scale is not given to you, but your horizontal scale is given to you. How do you work out your your vertical scale? You're saying now, because my vertical scale is not given, but what I know is that the vertical interval on the map is 20 meters, then what do you say? You say, how many centimeters are there? How many centimeters are there in a meter? How many centimeters are there in 1 meter? Then you say there are 100 centimeters in a meter. Then you say now, which means now you have to get 100 centimeters in each meter, and you multiply that by 20 meters. Then you're going to get 2,000. Vertical exaggeration. What is the formula for vertical exaggeration? Vertical exaggeration is equals to vertical scale over horizontal scale. I think we get that. Now, how do you calculate vertical exaggeration? You divide your vertical scale by your horizontal scale. What is your given horizontal scale? Your given horizontal scale for your topographical map is 1:50,000. And for your orthophoto is 1:10,000. In this case, we're going to use a vertical scale. We're going to use a horizontal scale of a topographical map, which is 1:50,000. So what do we do now? We say the horizontal scale is given is 1:50,000. Are we given any vertical scale? No, we're not given any vertical scale. But what information do we have? We know that our contour interval on the map is 20 meters. Now, how do we get our vertical scale? How do we get the vertical scale? You say how many centimeters are there in a meter. There are 100 centimeters in a meter. But now our contour interval is not 1 meter. Our contour interval is 20 meters. Now we're saying 100 centimeters multiplied by 20 meters is equals to 2,000. It's going to be 2,000. Now we have worked out our vertical scale. What is our vertical scale? 1 is to 2,000. Our horizontal scale was always given as 1 is to 50,000. So we have to divide this. We say vertical exaggeration is equal to vertical scale over horizontal scale. So what do we do now? We say vertical scale. We say vertical scale, it is 1 over 2,000. It is 1 over 2,000, and our horizontal scale is 1 over 50,000. 1 over 50,000. But now you cannot divide a fraction by a fraction. So instead, what do you do? You say 1 over 2,000 multiplied by 50,000 over 1. So what do you do there? 50,000 times 1 is 50,000. Then 2,000 times 1 is equals to 2,000. So what do you get there? You say 50,000 divided by 2,000. So you do a simple, you simplify. So you cancel this 3 zeros by these 3 zeros. Then you have 50,000 divided by 2. So how many times does 2 goes into 50? It goes 25 times. So it means now on the topographical map, our vertical scale is exaggerated. The features on the topographical map will be exaggerated 25 times for them to be clearer. So our vertical exaggeration on the topographical map is done 25 times. So when you're looking at a feature on the topographical map, you are going to exaggerate it 25 times. Why do we do vertical exaggeration? To make the features to be clearer. So we're going to exaggerate it 25 times to make it clearer. Let's continue with our Mapwork. Here. So now, use the topographical map evidence. What has happened here? Okay. Now, use the topographical map evidence in your answer to the previous question and give 2 reasons why it will be difficult to construct a road. Okay, this one is it's a gradient calculations. This one is a gradient calculation. It's not a vertical exaggeration. So what are we looking at here? Contour lines in the topographical map is very close. So why is it going to be difficult for you to construct a road here? It is because the calculations here not calculation, sorry. It's because the contour lines will be closer to each other. Okay, let's move on. Let's look into our map interpretation. The dash in block E2 on the topographical map is an indication that seasonal rainfall occurs in the area. Now, you look at these things. Is it the row of trees? Is it perennial river? Is it a non-perennial river? Is it cultivated land? Now, what do we have there? You have cultivated lands there. Do you have any perennial river here? You don't have any perennial river. So what is the indication that will show that what will be the sign that indicate that the area receives seasonal rainfall here? It will be the non-perennial river. It is an indication that the area will receive periodic rainfall or seasonal rainfall. The non-perennial river. And then how is the non-perennial river represented? The non-perennial river is represented through the dots. It's represented through the river that is not flowing throughout. The river line is broken. But for the perennial river, the line is solid. Now, let's look at your map interpretation. Here is the question. Refer to the graph below indicating the average temperature of the area from H in block C1 to J in block C4 on the topographical map. Now, let's look at the questions here. Identify the man-made feature that was responsible for the higher temperature recorded at X. So here is our point X. And now we have that. Why will the temperatures be higher? So what must you identify? You must identify man-made. Remember, in our previous slide, we're talking about the temperatures in urban areas and rural areas. Where are temperatures higher? Temperatures are higher in urban areas than in rural areas. Now, we must give the reason why are temperatures higher in urban areas. Number one, the tar roads, constructed buildings, these are the features that are going to make the temperatures to be higher in urban areas than in rural areas. And now, when we're looking at this rural area over here, what will make the temperatures to be cooler at this point? Why will temperatures be cooler at this point? Number one, you can see there's vegetation there. You can see there's a river there. So these are the natural features. So the question could be, what is the natural factor that are going to make the temperatures to be lower here? It is the natural vegetation here. It is also the river that are going to make the temperatures higher. Lower. And then what will be the factors that make the temperatures higher in urban area, in the built up? How do you see urban area on the map? You see the gray area is indicating the built up area. So also these are the type of roads that are also seen in the urban area. So the factors that are going to make temperatures to be higher here is built up area or constructed. The gray area is indicating this is a built up area, and also this is the tar roads that are going to make the urban areas to be warmer. But you're looking at the natural vegetation, and the rivers are going to make the rural areas cooler. And then because of that, this one will be cooler, and then pressure gradient will be created. So this will be high pressure, and this will be low pressure, like in our previous slides. So air will be moving from rural areas to urban areas. So this is a typical example of what we spoke about when we're talking about urban heat island in the earlier slides when we're talking about temperatures. So temperatures will be lower here and will be higher here. So you can see here temperatures are lower, and as you go up, the temperatures are increasing. When you're moving from that point going there, this is your J, indicating the temperatures are lower. Why are temperatures lower here at J? You can see the graph here showing temperatures lower because you can see there's a river there, there's natural vegetation there. But when you go into H here, H is in urban area, so you can see now the graph is showing temperatures that has gone higher. Because of what? Because it's urban area with artificial surfaces that absorb heat, with roads that absorb heat, with more human activities. So urban heat island, when it comes to Mapwork, that should be the simple thing that you can do for yourself, because it's going to be easy for you to interpret it, because it is showing there on the map. So I expect everybody to get that. Why is temperatures low here and why is temperatures high here? So you have all those factors that makes temperatures to be high and low. And because of that, it's going to result in pressure gradient. Let's continue with our interpretation there. It's the same diagram that we are looking at. Now we're looking at the factors. Explain your answer to the previous question. So we have explained that we're identifying. So what were we doing here? we're simply identifying. So you will identify what are the features. Now, after you have identified the features, you have seen these features that makes temperatures to be low. The feature here is water. The feature here is vegetation. And then the feature here is road, and the feature here is also built up area. Now, we're taking it further. We're saying you're no longer identifying now. You're saying you explain now the answer. Why are these features making temperatures higher in urban areas, and why are these features making temperatures lower in rural areas? Now we're saying the tarred roads and buildings in the city town absorb heat and retain the heat, which will increase the temperature in this area, resulting in urban heat island. And then what will happen now in rural areas? Temperatures, natural surface are going to reflect, or trees are going to absorb. Here we're saying trees here are going to absorb heat, and you can say water masses are also going to moderate the temperatures. Now let's look at this other one. Okay, we have already done that. Now, another way of map interpretation can also be katabatic and anabatic winds. So if they say name the winds that will blow from A to B at night, the weight at night must tell you already that we are talking about valley winds. We know that we are talking about valley winds, and these valley winds must be during winter. So if they say during night or in the valley, you must know those winds. So long as you see the word night, you must know it is katabatic winds. And when they describe the nights these winds will blow, katabatic winds are going to develop during cold winter nights. It is going to be cold, calm winter nights. So there must not be winds. There must not be wind. It must be wind still. Because if the winds are blowing, it will not be clear. So this over here, you are going to have something like this. You're going to have something like this. So this is your katabatic winds. So during which season do they form? They form during cold winter nights. The first process that will take place will be terrestrial radiation, loss of heat by the surface. Then the cold air will go to the bottom of the valley, and it's going to force the warm air that was trapped in the bottom of the valley to move upslope. But the warm air will not move out of the valley. It will be trapped there in the middle of the valley, forming what we call thermal belt. Forming what we call thermal belt. My handwriting is a little bit terrible on a slippery surface. I'm writing on a very slippery. So that is called thermal belt. So what does this thermal belt show you? It shows you temperature inversion. And what's going to happen? More cold air is going to subside to the bottom of the valley. When more cold air subsides to the bottom of the valley, what's going to happen there? There's going to be frost pocket forming there. Frost pocket are going to form there in the middle of and at the bottom of the valley. So it will be during cold winter nights. And I think I came to the end of the revision for paper 1, and I would like to thank you for paying attention and for listening. Thank you. We shall see each other again when we do revision for paper 2. I thank you. good day, learners.